Hello and welcome everyone to what will probably be, at least for the time being anyway, our last video lesson, definitely for indices. In this lesson, what are we going to do? Well, we've pretty much finished indices. So this lesson is going to be a review of everything that we've covered in indices. So that includes going through the expanded and index notation. We'll have a quick look back over all four of the index laws. And I've got a couple questions at the end, those sort of harder combo questions, which is the questions where there's like multiple index laws that are all added into the one question. So that's what the lesson is. I guess, look, let's just get straight to it. So here we go. Just like always, you will need book, pen. You can probably get away without the calculator yet again. Indices has been pretty generous to us in that regard, but you will definitely need book and pen. Our title for today, here you can see it, it's Indices Revision. So pause the video, copy in our first section. Once you have it in, press play and follow along as we go through it. So first skill we covered in this topic was index notation. The way it works is really simple. In this case, we're not trying to evaluate to find the answer, which you actually could do for the first two. It would be impossible to find answers for these bottom two because there are unknown numbers. But that's not what we're practicing here. We're not practicing finding the answer. We're just practicing writing something out in index notation. So 2 times 2 times 2 in index notation would be 2 to the power of 3. The next one, you've got like two different bases, right? You've got this base of 2, 2 times 2, which in index notation would be 2 squared. And it's been multiplied by 3 times 3 times 3, which would be 3. The base stays the same. Ultimately, you're kind of adding the powers, but yeah, it's 3 to the power of 3. All right, for this next one, we have a times b times b times b. So we've got an a there. Technically, there's only one a, so I could have an a to the 1 if I wanted, but that's never necessary. I'm just going to leave it as a, and then b times b times b is b cubed. Notice the difference between this one and the one above. I don't need to include the times sign in between. With the numbers, if they're actual known numbers, you do need to include the times sign because that can be a little bit confusing for people in terms of what it actually means. But with algebra, there is no confusion. So if you wrote it as a times b cubed, that is still correct, right? Whether you have the 1 there or not, that's totally fine. But with pronumerals, it's not necessary. Whenever there's two pronumerals right next to each other, that actually means times. It means the same thing. Right, and on to our last question for this page, index notation. We've got the 5 times 2. I guess it probably just makes sense just to times them out to get to 10. There's no indices really to worry about there with it, other than, the indice of 1. But here we go, we have x times x. So that will be x squared, and we've got y times y. That'll be y squared. All right, so that's index notation. So in your topic tests, which you'll see on your Canvas page where you accessed this lesson, there will be questions that will ask you to write out the following in index notation, right? And this is how you do it. They don't particularly get hard, so that's kind of it there. All right, the next one. Now, writing out something in expanded notation, so that's just the opposite of what we just did. Here we have some questions that are written in index notation. Now, what we're going to do is we're just going to rewrite them in expanded notation. So in this particular case, 7 to the 4, that would just be 7 times 7 times 7 times 7. That's expanded notation. It's not asking you to work out what it's equal to, right? Nothing like that. The question you'd be given would be legitimately write out the following in expanded notation, right? Or write out the following, in expanded notation. All right, this next one, x squared, what would that look like? Well, it's just going to be x times x, let's be honest. This one here, x squared y, x times y, right? That's how you'd write it in expanded notation. And the very last one would be 2 times x times x times x. And you can see why I'm doing my x's a little bit curvy. Otherwise, they just look like timeses, you know, and everyone's getting confused. What's times? What's x? You know, so we try and, like as mathematicians, because the way most people write an x is the same way as they write a times, we try and differentiate it so people don't get confused. So typically, you know, you might make the times a different size to the x's, and we typically might write the x's a little bit curvy, just to, again, make it as obvious as possible. Just one side point with expanded notation. If we go back up to the top one, I chose the number 7. I did that deliberately because it's a prime number. If I'd given you something like, 6, for example, you know that could be written out as 6 times 6. The reason why I avoided that is because, I guess technically you could actually expand this even more. And the way you could do that is, well, the 6 is, of course, 2 times 3. And that 6 could be like expanded more into 2 times 3. And, lots of people will have different opinions about, should you be doing that or not? And because everyone sort of has different opinions about it, I'm actually just going to sort of really leave that. And so what you'll find in your topic tests, when you guys are doing the test for it, I'm just sort of going to be sticking with your prime numbers there. So you won't really have to worry about, should I be breaking up the number further or not? It'll be a number like 7 where it can't be broken up anymore. All right, the next skill, index law number 1. So this was the one where when multiplying, base stays the same, the powers add. So how does that look like? In this case, our base is n, base stays the same, and we add the powers, right? So when multiplying, the indices add. The base stays the same. And by the way, if you're wondering, why is that, right? Go back to the lesson when we covered index law number 1, and that was all explained about why it is that they end up adding. We went through all that then. So if you have forgotten, by all means, you're welcome to go back to that lesson and just rewatch that part again so it makes sense. But if you're just wanting to get through the topic test and get good scores, that's all you really need to remember. You don't even really need to worry about why it works, just that it does. So for this one here, what would this be equal to? Again, the base is x, the base stays the same, you add the powers together. This one here, the -7 and the 2, they are not indices, right? We don't use index law for normal numbers. The index laws, we only use on indices, right? Makes sense. So for a normal 7 times by a normal 2, guess what? They're just normal numbers. We multiply them like normal. So you'll end up with a -14 there, which was 7 times 2. Take the negative out the front. And then when we go on and look at the base and the indices with the x's, this is where we use index law. Base stays the same. You add the powers. Hopefully that made sense. That was probably the hardest question here on this one. This one here is pretty simple. You end up with a to the 4, b to the 12, and here you just left with a c to the 1, or you could just leave it as c, right? So that's index law number 1. And again, if you need to look back over stuff, you can. Very crucial, very useful. There'll be lots of questions on index law number 1 in your topic test. So make sure you're comfortable with these sorts of questions and this sort of difficulty, right? So if you're finding these 4 questions pretty easy, you should be in a pretty good position for index law number 1. Right, what was index law number 2? This was the divided by 1, where the indices subtract, right? They minus. So what that means is the base stays the same and you subtract the powers. In this case, it's a 6. By the way, this would work even if n was known. If it was, say, for example, the number 7. if you were evaluating this in index form, base stays the same, take away the powers, right? That's what it is. It's 7 to the power of 6. Anyway, let's move on to the next one. Okay, so sometimes the divided by, instead of being written, like this, sometimes divided by can be written as a fraction, where you have some number divided by some other number. And if you look at the actual symbol for division, hopefully you can see why that's the symbol we use for division. The dots represent numbers. It's a number that is being put over another number. They're being divided by each other. That's actually where the division symbol comes from. So here we have divide. So it doesn't matter if the division's written like this or this, it's done the same way. The base stays the same. You take away the powers. You should end up with x to the 20 there. This one here, we do have some ordinary numbers, which we're dividing, right? That 10 and that 5 are not indices. So we can't use the index law on those numbers. They will just operate like normal. 10 divided by 5 is 2. Now, when we look at the indices, that's when we use our index law number 2, because we're dividing those indices, subtract. And b, here you would end up with b to the 10. All right, on to our last question. I've written the division like this. The reason I've done it like this is because we're going to be left with a fraction anyway. 20 divided by 30, they're not going to go away completely. They do simplify down into a 2 over 3. And then the ends, these ends have indices above them. So this is where we'll use our index law. 7 minus 4 is 3. So you'd have it like that. Or some people, might prefer to write it like this. They're both identical things. So it doesn't matter which way you go about it. Some people, who really enjoy their decimals might even write their answer like this, which is also equally valid. All right, index law number 2. So hopefully that's making sense for you. By the way, I mentioned at the start, but you should be getting these into your books. So I kind of forgot to mention it a bit. If you're just trying to memorize it, I'm not going to hold you to it, but I'm going to strongly encourage you to be getting these questions in your book, just so when you're revising, you got everything right there ready for you. It just makes things a little bit easier when it comes to that. Index law number 3, this was the power of a power one. So the base stays the same and the two indices multiply. Okay? So when times in, they add. When dividing, they subtract or minus. And when you have the power of the power, this is when the two indices, they multiply together. So this one here, there's two different bases. So again, the multiplications just work individually. So 1 times 11, move on to the y, 4 times 11, and you end up with your answer. And for the bottom one, here we have an ordinary 5, which has been squared, right? That 5 is not an indice. We can't be using index law for it. We do it like normal. 5 squared means 5 times 5, or in other words, 25. And then the x to the 10, this is where we use the index law, and you multiply the two indices and you get your answer. So that's index law number 3. If you are copying this into your books, now's a good time to pause the video. Make sure you have this in your book. Before moving on to our last section of the lesson, we're almost there. Oh, actually, second last section. We do have index law number 4. Fortunately, it is the easiest of them. This is the 0 index. Any number taken to the power of 0 is equal to 1. Again, it was explained in the video. It was shown why. So if you're curious, you forgot, maybe you skipped that lesson, you really should probably go back and look at that lesson. But either way, I'm just going to go ahead and assume that you know why. So as far as the actual questions you're going to be given, there'll be questions like this, right? These are the sorts of questions you have in your tests. 7 to the 0. Any number to the power of 0 just becomes a 1. So in this case, we have a to the power of 0. Again, I don't know the value of a, but it's been taken to the power of 0, so the whole thing will become a 1. Just to take that concept even further, right? Any number taken to the power of 0 will become a 1. So here you have 3a, which is some number. I don't know what it is, but that whole thing, all of 3a is being taken to the power of 0. So the whole thing just becomes a 1. Which is a little bit different from the last question, because in the last case, has everything been taken to the power of 0? The answer is no. That 0 indice is only applied or attached to the a. So it's only the a that becomes a 1. So you actually have 3 lots of 1. So in other words, your answer for the final one will actually be the number 3, right? That's sort of really the only situation where index law number 4 can be a little tricky, right? Don't just throw down the number 1 for every answer. You actually will be right at least half the time, but there are trickier questions where that's not the case. All right, now it is last section, the mixed questions, ones where there's different index laws all combined. If we look at the first one, there's only 2 for us to do, by the way. If we look at the first one, right, what do? I'm just going to take things in steps. Let's look at the numerator, the top part of the fraction. I can see that's just index law number 1, right? When multiplying, keep the base the same, add the powers. Down the bottom, power of a power, index law number 3. So we've got index law 1, index law 3, base stays the same, and you multiply the powers. All right, so that's our first step. Now from here we can see we're actually left with one extra part to do, and it's an index law 2 question. We've got these 2 things that are dividing. When dividing, keep the base the same and minus the powers. And that's your final answer there. All right, on to our final question of the lesson. All right, so I'm going to start with the numerator. Here we've got an index law 3 question, and a tricky one at that, because that's a normal 4 here. That's a normal 4 that's been squared. So what is 4 squared? 4 fours are 16. And then you're left with this p, right? Power of a power. In that case, you multiply, you end up with p to the 14. And it's been times by p to the 0. Well, that's index law number 4. That just becomes a 1. And then the whole thing has been divided by, okay, look on the bottom, we have 88 divided by 11. That gives you 8. There's a p there. H divided by h, they will cancel. So you're just left with an 8p on the bottom. 16 times 1 is still just 16. So I'll leave that there. And, you know, what's my final step going to be? Well, we're left with another index law 2. 16 divided by 8 is 2. And when dividing, keep the base the same, subtract the powers, and you get final answer. So your topic test for this week, and like your topic test for indices, it will have a couple of these questions at the end. You know, and again, when you're going through them, don't panic. It's just a matter of just taking your time, do each thing just step by step. You know, if you need to write out, like break it down into 4 or 5 steps, go ahead and do it. Typically, you'll find, just like this one, typically 2 or 3 is all that's going to be needed. But yeah, just do each part, you know, separately, and you should eventually end up getting, you know, hopefully, well, the correct answer. All right, as always, I hope the video helped. If you do have any questions, you know, feel free to leave them either here on YouTube or back on Canvas. And I'll see you guys for the next one. All right, bye.